Alright, so for today what we're going to do is we're going to write equations of parallel and perpendicular lines, but it's going to be part 2. Alright? Yesterday we did parallel lines. Alright? Today we're going to do perpendicular lines. Okay? So let's move on. What do we know about perpendicular lines? They cross to form 90-degree angles. Excellent. So lines that cross to form 90-degree angles. Hello? Hi. Okay. Yep. Bye. Alright, so lines that cross to form 90-degree angles. Yes? Okay? If you remember yesterday we dealt with parallel lines, correct? And we said they never touch, so they had the same slopes. With perpendicular lines, the slopes, they're called opposite reciprocals. Opposite reciprocals. Okay? So let's talk a little bit about that for just a minute. When we talk about opposite reciprocals, let's say, for example, I have the slope of 2/3. Yesterday, when we said they were parallel, what was the slope of the new line? 2/3. Today, when we do it, okay, this is perpendicular. Notice that my symbol is like an upside down capitalized T. When we talk about the opposite, this is positive, correct? Then the opposite is going to be negative. And then when I say a reciprocal, what am I doing with my fraction? I'm flipping it. So it becomes 3/2. So what you're going to do is you're going to take your fraction. If it's positive, it's going to be negative. If it's negative, it's going to be positive, and you flip it. So you do two things with it. So another example, let's say m equals -4. If I'm going to do perpendicular, m equals, first of all, this is negative, so my new slope is going to be positive, and rather than 4, it's going to be 1/4. That's right. I'm going to flip it, so it's 1/4. If my slope, and here's a tricky one, is 0, and I'm doing perpendicular. Now think about it. What type of line has a 0 slope? It's horizontal, right? So something that's perpendicular is going to be, if it's perpendicular, it's going to be vertical. So what's the slope? Undefined. Yeah. So then this is going to be undefined. And it's not going to be positive or negative because you can't have a positive or negative 0. You can't have a positive or negative undefined. Yep.
So if you have an undefined slope, it would just flip it to be 0?
That's correct. So she's saying if my slope is undefined, that means I have a vertical line. If I'm going to do perpendicular, then it would be horizontal, be 0. So they're kind of like back and forth. Okay, good question. We all right? All right. So let's go ahead and let's move on to the problem and look at the example. So the first thing I'm going to do is I'm going to take this equation. What is the slope of this line? Is 1/3. And if I'm doing perpendicular, my new slope is -3/1 or just -3. And this is the slope that we're going to use in our equation. So what I'm going to do is I'm going to take the x, comma y, y equals mx plus b. My y is 4, my m is, my x is, my b is b. So we're doing the same thing as yesterday. The only thing that's different is that slope. So 4 equals -9 plus b. I'm going to add my 9. So I get 13. So my equation is y equals, that's right. It does not ask for it in standard form, so I'm not going to put it in standard form. If they ask me to, then you can. Questions? Yep.
So we keep the new slope in the
You keep the new
model?
slope.
Okay.
Do not do the old one. Okay? So what's happening is this. You have something like this, all right, and you have that point which is 3, 4, so it's like here, all right, and then you have this equation which is like, you know, here, and it's like this, and they're asking you to come up with an equation that goes through this that is perpendicular. You aren't going to graph anything for me. Okay. Is that something that you could get in geometry? Absolutely. Now you'll notice that we spent a day on parallel, we spent a day on perpendicular. We're going to spend a day reviewing, yes? When you get this next year, we spend one day on everything, and we move. Okay, so you're going to notice as you get older, we don't spend as much time on things. And it's just as hard, if not a little bit harder. Okay, so this is something you really want to get, and next year you'll be like, oh, cool, okay, I can do this. Okay. All right, good questions. Let's take a look at this. Determine if line A is perpendicular to line B, and justify your answer using slopes. So does it ask you to graph anything? It does not. So if I'm going to look at the slopes, what do I need to do? Yeah, I need to see if they're opposite reciprocal. So I'm going to pick up my equation of x, y, x1, y1, x2, y2, m equals y2 minus y1 over x2 minus x1. How many times have we worked with slope?
Tons of times.
Tons of times. Do you see why I had you write down that formula? It's so important because as soon as you start getting it wrong, like the rest of how many chapters, you're going to have trouble. Okay? So I'm going to go ahead and find it. So line A, the slope is 1/2. Line B, you're just doing the work. When you get done, you look it up just to check to see if your answer is right. That is the best way to do this because you've done this before. This is nothing new. Are the slopes the same? They're not. So I know they're not what? I know they're not parallel. Okay, now, are they opposites?
Yes.
Yes, line A is positive, line B is negative. So that's yes, that's a yes. Are they opposite or reciprocals?
Yes.
Yes, they are. Because 1/2, if I flip it, it becomes 2/1. So are these perpendicular? Yes. So you're going to write yes, perpendicular, slopes are opposite reciprocals. Done. But you need to justify it. Don't just like leave it hanging. Make sure you finish the question. Yes, ma'am.
What if it's, like, if we hit this on our homework, what if it's not? Like, what if they're parallel?
So then you'll say slopes are the same, they are parallel, so they're not perpendicular. Or if they're both, let's say they're both positive, so you'll say no, they're not perpendicular because they are reciprocals, but they're not opposites. So like, talk about it. Okay. Good question. Any other questions? All right, let's move on. Determine if the lines of any are parallel or perpendicular. This is really like geometry. Like this problem is like right out of the geometry book. It's also out of ours too. But let's take a look at line A. What do I do? That's correct. So I need to take these equations and I need to put them in y equals mx plus b form, and then I compare m. So I compare the slopes, is what I do. So how do I get the first line in slope-intercept form? So do I divide by -3 right away? No, what do I do first? Yep, I'm going to subtract 12x. So I get what left over? -3y, not just 3y, equals -12x plus 3. And then we divide by our -3. So then we take it and divide by -3.
Couldn't you just have multiplied by -1/3?
I could multiply it by -1/3. However, when we solved for y in the past, like why are we changing what we're doing? You know what I'm saying? Like we've always said, get x to the other side, then divide. Okay. So that's what we've been doing, so why change your ways? Because it worked before. But yeah, you probably could. All right, so what do I get? Y equals 4x minus 1. What's my m? 4. Or 4/1. Okay? All right, so that one's done. Line B. It's good. Yeah, it's in y equals mx plus b. What's my m? I have a problem like this right on the test. Like it's almost identical. So if you know how to do this, you're good to go. Okay, this is that 6C standard. What about line C? So I need to do what first? Subtract x. So 4y equals -x plus 8. Now what? Divide by 4, right? So y equals -1/4. Yep, there's a 1 in front of that x. X plus 2. Don't forget the x, because I got a couple of kids. That's what you're doing. You'll notice that it's bottom heavy because it's divided by 4. There's still some of you that put -4 there. It's -1/4. Okay, so my slope here is -1/4. Yep. Right now, am I done? No, because it says determine if they're parallel or not. So let's take a look at line A and line B. Are they parallel? Yes. Why? Same slopes. So A is parallel to B and same slopes. So you need to make sure you answer those questions. Yeah, if I say A is parallel to B, then yeah. I don't have to say B is parallel to A. Okay? What about A, line B, and line C? Are they parallel? No. Are they perpendicular? Yes, they are. Yep. So B is perpendicular to C, and we'll go slopes. What?
Slopes are different. Their slopes are opposite or something.
Right, opposite reciprocals. This will be on your NWA in the spring. So it'll be on your plan text next year. It'll be on your ACTs. Yeah, it's exciting. It's not hard. It's just remembering, okay, why? Yep, you have to do it. Okay, now, am I done? No, why not? I still, okay, so I still have to look at A and C, right? Are A and C parallel? No. Are they perpendicular?
No.
Yes. So A is perpendicular to C. Slopes opposite reciprocal. We're done. Yep, that's it. Yes, ma'am.
So if they're opposite, it's like if one is automatically.
Not necessarily. So if I have M equaling 3 and the other one is negative 3, they're not parallel because they're not the same. They're not perpendicular. They're just opposites. They also have to have the flip to them. So if it's 3, then it's 1 over 3. Okay, so that they're not perpendicular. They're just going to intersect is what's going to happen because one goes one way and one goes the opposite way. Okay. Any other questions? Awesome. Okay.